Hello everybody, welcome to this new tutorial. In this tutorial we are going to talk about how to calculate non-carcinogenic health risk and carcinogenic health risk using Python. So if you are new to Python, then just head over to anaconda.com and install Anaconda in your local computer. So if you are stuck, then you can check out my previous tutorial on water quality index calculation. There, however, I have described those things: how to create a new notebook in Python, how to calculate, how to install Anaconda. Okay, now so let's get into the video actually. So after opening a new notebook, then we are going to load our data. So to load our data, you have to import pandas. So we are going to import pandas as PD. If you haven't imported it as PD, then you have to write here like pandas.read excel. So just to make it simple or easy to write. So this is our excel file name, water quality, and this is the extension. If you have a CSV file, then you have to write here water quality.csv. Okay, and here you have to write pd.read csv. Okay, fine. Now let's see our data. So this is our data. Latitude, longitude, we don't need those things, and we will use iron, manganese and arsenic to calculate non-carcinogenic health risk. And to calculate carcinogenic health risk, we will be only using arsenic concentration. Okay, fine. Now let's see some basic statistics about it. So you can see like df dot describe so now it returns you some statistical analysis, basic statistics like standard deviation for each column, and here mean for each column, and 25 percentile, 50 percentile, etc. Okay, now what? Now let's see our data a little bit, visualize our data. So it's actually, I want to see for, where is our union? Shit, man. There it is. I want to know from each union how many samples I have collected. So to do that, we have to group our data, like group by union, and we want to count samples. For example, we want to count bicarbonate samples from each union. Each union, here union means actually location, from it's like a state you can say, but in our case it's a union. So from different locations, how many samples we collected, that's it here. And you can see over here Kaizuri union, from this union we have collected highest number of samples. You can actually see that. See, from Kaizuri 13 samples. Okay, cool. Now we can also see some regression between, say for example, bicarbonate and arsenic. So I'm just showing you this graph. You don't need it to calculate water quality, carcinogenic risk. So you can do such things with Python very easily. Okay, now if you would like to see correlation between different water quality parameters, then you can like df.corr. Then let's see. Now you can see between bicarbonate and iron correlation is positive, and highest correlation found in between bicarbonate and magnesium, it's 7.71, and by default this correlation is Pearson correlation. You can also change it to like what, a Kendall, Spearman, etc. Okay, if you want to extract only one column from your data frame, what you have to do is write df dot column name. Say for example calcium column. See, it's a calcium column. Fine, and we will see that in our function how to pass all of our concentrations at a time. Let's see how to build a function in Python, and to calculate our carcinogenic health risk we will be using, for non-carcinogenic health risk we will use this equation, that is ADD divided by RFD. Here ADD is average daily dose and RFD is reference dose, maybe overall reference dose. So to calculate ADD you need this equation. Here says concentration, IR ingestion rate, ED exposure duration, and EF exposure frequency, and now body weight, average lifetime expectancy. Fine. Okay, you have to at first make a table about those variables. So I have divided my population into 3 age groups, and here is their body weight. Okay, and ingestion rate, first group 1 liter, second one 2 liter, 2 liter, exposure duration, and its age dependent adjustment factor. It's actually for carcinogenic health risk measurement. We'll see that in this video, later in this video actually. So so let's see how can we write this equation in Python. Now back to our Python notebook. So at first we are going to drop those unnecessary columns, some of them. So your in place true is actually to update our data frame. If you don't pass this in place true, then these columns will not be permanently deleted. Okay, now for non-carcinogenic, let's say actually how can we build a model. So let's define a function df. Function name, you can give any name to it, like name, then in a parenthesis provide inputs or arguments, like I am going to seek and concentration and ingestion rate. Okay, or you can say at first say x comma y. Fine. After that you should have here 4 lines of space. Indentation is must. Okay, now let's say return x plus y. Now we have to call our function name to execute this function. So name, now give values of this function 2, 3. Okay, you can get 5. So another way to do the same thing is like we are going to store this result in a variable called z. Z is equal to x plus y, then return just z. Run it, same result. Let's say you want to multiply it by 5, Okay, 25. Pretty easy. Okay, now we can also store our result in a variable like x is equal to our function actually. So now run it. Now if you call x, you will get 25. Okay, pretty easy. So let's write our health risk equation. So we are at first we are going to write this equation. So to write this equation we need some variables like exposure duration, EF, body weight, AT, and finally this equation. It's just a plain equation, it's not a big deal actually, and then return ADD. Okay, after we have written our function, then we have to call our function. Here we are calling our function, and in the concentration we are passing df dot iron concentration, 64 iron concentration, or how many columns of data you have, all of them at a time. And here one is iron ingestion rate. For my first age group, that is 0 to 5, ingestion rate is 1. Okay, fine. So we are storing this data output into this variable ADD. So after that, the final equation is divide ADD by RFD. So here outside the function we have stored our RFD RF in a variable called RF, and for iron RFD is 0.7 milligram per liter maybe. Okay, then final hazard quotient is ADD divided by this RFD, and what Python does here is called broadcasting, because this ADD is 64 by 1, that is 64 rows 1 column, while RF is just one single floating point. So it's called broadcasting. Python thinks we have 64.7 RFD data we got. Okay, fine. Now just let's print it. Now see, this is our hazard quotient for iron. Now we want to add this data to our data frame, original data frame. So to make a new column, what you have to do is just write data frame name df, then this is our new column name. So this was for iron, so I written here iron hazard quotient for age group 0 to 5, and this column will take what output? This hazard quotient, what we have calculated here right now. So it is HQ. Okay, now let's see our data frame df. You can see now here one additional column is included, and this is this one. Okay, fine. Similarly we have to do for other age groups. So this is for second age group. Now it is 10. Okay, fine. Now it's for iron, and here ingestion rate is 2. That's it. Okay, again run it. Fine. So I'm not going to do that for 3 age groups, I am just going to do that for 2 age groups. Now again you have to do it for manganese, and now what will change is this RF. For manganese RFD is 0.14, so we have to write it 0.14. That's it, and make sure that you have changed here the column name. For manganese, right here manganese. For iron. Okay, then run it. Again for another age group, run it. Now let's see our data frame. So now you can see over here we have hazard quotient for age group 0 to 5 for iron and age group 6 to 15. Similarly for manganese. Now what we will do is, the next part is, we will add this column to this column. So because now we are going to calculate hazard index. To calculate hazard index, you have to add same age group hazard quotients for different chemicals, and you will have hazard index for a particular age group. So to do that, you have to slice your, no, I don't need to slice. So I need just this column at first and this column. So how do we do that? One way is df ilog, and then in this I can just, so how can we do that? df dot ilog, at first see the shape of data frame is HAP. That means we have 64 rows, 14 columns. Okay, 64 rows, 14 columns. And Python doesn't count from 1, it counts from 0. So this column is 13 and this one is 12. Okay, it's 11, it's 10. So now we need 10th column and 12. Fine. So to index wise extract columns, the method here is ilog. Then give it a input, and input must be in a list. Sorry, give it a input at first semicolon, sorry, colon. Colon means we are selecting all the rows, then comma. We need, if we need 14 column, then we have to specify 14, but we need more than one column. So again give a square bracket, then specify your column index. Here it's 10 and it's 12. So we're going to give here 10 comma 12. That's it. df 05 manganese 05, and our task is to add both of them up. Okay, so to add them up, we are going to write dot sum, and in bracket you have to specify x is equal to 1. X is equal to 1 means we are going to add them up in horizontally, actually, not vertically. If you don't provide the x's, then it will sum them vertically. Okay, and we don't want that. Okay, and we want to store our output in a new column. So df make one new column. Let's write it hazard index for group 1, GRP1. Cool. Okay, execute it. Let's see df data frame hour. So now you can see our data, one additional column, hazard index for group 1. Similarly, we can do it for second age group. Copy it and paste it. So you have to just specify here 11 and here 13 and here age group 2. let's see df. Fine, we got our hazard index for both of the age groups. Okay, another way to do that I have shown here. How to do another way: just here you don't need to specify which column 14 16, just specify number, provide the name of the column. And if you provide name of the column, then you have to change it from here. We provided iloc, and here the difference is you will just provide loc, that is locator, not in index wise locator, it's level wise locator. Okay, fine, it's the same thing. Well, now let's see our dataset df, and now you can see right here our hazard index for two different age groups. Now let's see the shape. So now we got 16 columns. Now we want to make a subset of our data for only hazard index. So let's say we now just create a subset for hazard index column of those two age groups. So I'm going to specify all the columns, rows, then I need column 15 and 16, sorry, total 16, so 14 and 15, because Python doesn't count last one. Okay, and now store it in a variable called hazard index. Fine, now let's see hazard index. Oh, good. Now I also want my union column, which is in the 0th index. That's it. Fine, now we can plot it like for different unions or locations, how hazard index varies. So to do that, let's hi.group by G. This is our average hazard index for different unions or locations. Now I can plot it. Dot plot kind is equal to bar, and increase the figure size, fig size to, let's say, 10 by 8. Nice. That's it. Now we can also sort it, like sort values by which column? By, let's say, group 1. Oh shit. Oh, dot. Fine. Now it's from descending. It's a ascending order, I think. Yes, from low to high. You can make it like descending order, like a, yeah. Descending is equal to false. So ascending is equal to false. Okay, false. Now it's high to low. Okay, that's it for hazard index. Now you can also export this hazard index map as a Excel or CSV file. So to do that, just write hi dot to excel, then give this Excel sheet a name like hazard index dot xlsx. Then in the folder you are running this notebook, Python notebook, this Excel sheet will be saved in that folder. Okay, you will find this folder in the same folder where you are running this code. Okay, that's it. I'm not going to run that. Comment it out. Now that brings us to the final step, that is carcinogenic health risk. So to carcinogenic health risk assessment, we will use this equation. So ADD will remain for us. Now here new thing is CSF, that is slope factor, carcinogenic slope factor, and ADAF, it's age dependent adjustment factor. So here age dependent adjustment factor for age group 1 4.3, for 2 it's 3. Okay, now let's go back to our Python notebook, and to calculate carcinogenic health risk, ADD is same, just here concentration is arsenic, because iron and manganese, they are not carcinogenic, so I am just going to assess carcinogenic health risk using arsenic concentration. Here this ingestion rate 2, because I am using this age group. Okay, then ADD, after that we will divide. Now CSF is for arsenic, CSF is 1.5 milligram per liter. So milligram per what, I don't know. So our arsenic concentration is in microgram. So to convert it in similar unit, we divided it by 1000. That's it. Okay, now this is the last equation, that is CSF multiplied by ADD, then age adjustment factor it is, and run it. You will have again the one additional column, that's like this. And you can export it, and you can do this task repeatedly for different age groups. So that's it for now. I think you found this video helpful. If you find this video helpful, then please subscribe, and if you have any question, let me know in the comment section down below. Okay, thank you. I hope I'll see you in another video. Thank you.